بسم الله الرحمن الرحيم والصلاة والسلام على أشرف المرسلين. In this video, I'm going to discuss and to show you how can we calculate the UV vis spectra for a simple compound. As usual, we have to build up the molecule, and we are going to build the molecule of formaldehyde. We go to R and choose the formaldehyde group, which is formyl group, which is the formaldehyde. It's hydrogen, carbon, and double bond O. So we have to go the calculation Gaussian setup, and we have to choose the opt frequency job, and the method we have to use the density functional theory with B3LYB, and at the level of 6.31 GD you can choose any level you have it. We can keep geomcon or we can delete it, and this is the UV, for example, for formaldehyde HCHO, and we can choose three shared processors simultaneously. We can go to preview and show our compound. This is our compound, and we want to calculate to minimize our structure firstly. Okay, submit this for the calculation Gaussian setup. I already did it, so we can cancel it. And after the calculation has been finished, we go to the file and we open it. Formaldehyde, we show it with formaldehyde opt log. This is the file, and we now go to this is the optimized structure. As you can see, this is the optimization curve, and this is the energy of our calculation. This is summary of results we have calculated at this formaldehyde, minimize it, and with no imaginary frequencies. And you can see the frequency calculations, vibrations for our molecule as usual. This is and you can start animation for this as we saw previously. Okay, now on the optimized structure, we have to go to calculation to Gaussian calculation setup, and we go to job type, and in this case we choose energy, the single point energy. Then to the method, we take the same level of theory, but now we have to change it to TDSCF. TDF or TDSCF, the method in the Gaussian makes it practical to study excited state systems since it produces results that are comparable in accuracy to the ground state DFT calculations. Okay, we return back to our compound, so that we choose TD B3LYB, and now the file is ready. We can change the number of the shared processor, and we can make a preview to show the file. And this is our file. The compound is TD B3LYB at the level of 6.31 in gas phase here. But then we can make submit, and I did it previously. So we are going to open the optimized structure, or the file which contains the UV structures. Okay, we can go now to open file, form UV log in gas phase, and this is our structure in gas phase. So we go to UV vis, and we show that there is a spectrum at 128.77 at this level. This is the wavelength at using a nanometer. Okay. Now we are going to repeat these calculations, but in aqueous solution. Okay, I did it before, but in this case we have to open our file, which is in water. Now, okay, the input file in water. This is our input file in water. Okay, we open the calculation Gaussian setup. We choose solvents as default and water as a solvents at the same level of calculations, and we make submit and optimize our structure in aqueous solution. After that, we open the optimized structure and run a single point calculation using TD-DFT method in order to calculate the UV spectrum in using an aqueous solution. The file is now ready. We have to open it in the solvent, UV in solvent, which is it? Yes, that is open. Remember that we have opened previously the log file in gas phase. Now we have both files on the screen. As we can see, this is in gas phase and this is in aqueous solution. We can now open the UV viz, and this is we have about 132.8, and in this case we have a absorption spectrum at 129. Also, we can open these files in Chemicraft. Open file in Chemicraft, formaldehyde, for example. We have it in solvents. We have formaldehyde UV. Okay, this is in gas phase. We can show spectrum, show the spectrum, and this is the spectrum. Okay, this is the spectrum of UV. We make it at this, which is about 100, the maximum absorbance with the absorption of 128.77, and this is an example only. We can open it now. Open the other file in aqueous solution, formaldehyde, aqueous solution, UV, formaldehyde, H2O, formaldehyde, opto UV in aqueous solution, and we can open the TD spectrum, and we can see that the spectrum, the maximum spectrum, is at 132.8. Okay. We can compare these values with the literature values. Also, we can open our source file, our output file, and we can check the 6 states: state 1, state 2, those states. There is a transition from 8 to 9 with a nanometer of 299, and this is the maximum we choose. And it is from the we can see which is the HOMO and LOMO. This is the HOMO and to LOMO plus 1. This is correspond the transition of electrons from HOMO molecular orbitals to LOMO plus 1, which is the number 1. And this is from HOMO to LOMO, which is about 300 nanometer.